Hi, my name's David, and today we're going to do another pair programming on LeetCode with my guest today, Ezekiel. Ezekiel, why don't you introduce yourself and tell where you're from?
Yeah, so I'm Ezekiel. I'm in the Tampa Bay, Florida area. And currently I'm a software engineering apprentice at Toledo.
Awesome. And fun question. What's your favorite movie? One of them.
My favorite
Yeah,
movie is probably Point Break.
nice. Okay, and what coding language are you going to be solving in today?
I think I'll probably use Java today.
Awesome. Okay, so today, can you navigate to number 389?
Yeah, sure thing. So find the difference. Cool.
Great.
So am I free to start?
So yeah, so take your time, read the prompt, and then explain to me the example to make sure you understand it. Afterwards,
Oh,
feel free to start coding whatever you're most comfortable with, and we'll talk about the time and space complexity at the end. You may begin.
okay, cool. So find the difference here. You're given two strings S and T. String T is generated by random shuffling string S and then adding one more letter at a random position. Return the letter that was added to T. Okay. Um, okay, that makes sense. So we're essentially having S, right? So there's string S, and then string T gets added some letter to it at random, and it could be shuffled at random. And we're just trying to figure out the letter that was added, if that's correct. Um, so if we look at this explanation, we have A, B, C, D, E was added at the end to T, right? So we would want to return E. Okay,
Nice, you understand it.
cool. Yeah, so I think the kind of approach I'm thinking of is there's a couple different options, right? So I'm thinking two routes. Either one, we could kind of split these strings, right? Um, and possibly throw everything into a hash set, right? Was kind of my first thought. And that would remove all of the duplicates, right? But that's not really what we want. We want to find the one that is unique. So what I'm thinking we do is
Mhm.
probably shuffle, basically traverse both strings, right? Add the cars and S to a hash map.
Okay,
Um, and then we'll loop through T and then check if a character is in the hash map. If it's not, then we know that character is the character that was added, if that makes
great.
sense.
That sounds like a plan. Why don't you type that out as a comment?
Okay,
What you just said, so it'll help people understand.
yeah, so I'm gonna traverse S,
Mhm.
add each card to a hash map,
Okay,
right? Then I'm going to traverse T and the car not in the map.
okay.
That makes
Go
sense.
go back a step. Your first step, traverse S and add each shard to hash map. So
Yep.
hash map has a key and value. So what would be
Yes.
key and what would be the value?
Yeah. So I'm thinking the key would be the car, right? And then the value doesn't really matter too much. I'd probably just make it 0, right? It doesn't really matter what the value is in this case. We really just want kind of O of 1 retrieval, right? For checking the hash map and kind of O of 1 placement, right? And so that's what what we're using it for,
Okay.
right? I mean, you could probably also add it to like some set, right? Um, and it'd be the same thing.
So to challenge that a bit, because that assumes that each character only appears once right? So what
Oh,
if,
yeah. So in the case that I have two like characters that show up twice, right? Mm, ha- ooh. Yeah, like we might want to look at the count of each character for each one, right? Because I could, I guess in kind of this case, right? We can look at this case in which I have S equals ABA, right?
mhm,
And then T equals ABAA, right? The difference is this A, so it would be in the hash map. So that's not the correct option, if that makes sense. Like this A would be in the hash map. So I guess in that case, we could probably like look at the count um, for each character. So traverse, so I guess we could change the steps then. So we would traverse S, add each car to the hash map, and increment its number, right? Like the value in the hash map would be the number, right?
okay,
And then we would traverse T and subtract uh, and subtract from the value, right? And then essentially, if the car is not in the hash map, or we no longer have like we no longer have the capacity of that car, right? Then
mhm.
it's the result. Right?
Yeah, that sounds like a good plan.
Cool. Um, yeah, so because this is Java, we have to do it a little bit differently, but I think we can kind of get to implementation right now, if that's all right with you.
Yes,
So essentially, it's going to be this car, or and then this will be int. We'll just call it map for now. We can do hash map, right? So then for loop through the first string s. Yeah, so we're gonna want to essentially loop through s, right? So s dot length. Plus, right? So essentially, we're gonna want to look at each car and add it to the hash map, and then if it's already in, then we'll just increment the count, right? So I'm gonna do if map ooh, map dot contains. I'm not working. So if map dot contains key, and we want to look at s dot car I, right? So if it contains that key, then we want to simply map dot replace s dot car I,
mhm,
essentially with dot get s dot car at I plus one, if that makes sense, right? So we're just incrementing what's already there plus one. We could
okay,
probably do plus plus, but just so it's a little bit clearer, right? And then if it's not there, else, if it's not there, then we want to map dot put s dot car I. Set that equal to 1. So that kind of is the first loop through S,
Okay, let's check if
right?
let's try to print this to see
Yes.
if it's working how you want it.
Line. What do we want to look at here? The entries that I worked with. Hash maps. I think it's a method. Yeah, I think it's a method, so we can try that. Unexpected type error. Oh, I probably have to use integer. And I probably can't, so I probably can't use the primitive types, right? So I have to use character. Yeah, so I don't believe dot entries exists.
You can look up any syntax.
So right now I'm kind of just heading to the Oracle docs. And then from there, I'm gonna look at instance methods.
Yeah, you can bring it in the screen if you don't mind.
Cool.
Wait, okay.
Okay, you can see that, right?
Yes.
Okay, great. So I'm gonna look at so there's the values, there's size. Oh, we want of the mappings. So I think we which version is this 8? A collection of values map. I'm pretty sure we can probably just return this and entry set if that's all right. So map dot. And that should give us the keys.
And then just have a placeholder return for now.
No, cannot be converted. So if we look, so in the case of A, B, C, D, so it looks like we are seeing A, B, C, D. So that looks correct. It's we're looping through this properly.
Yeah, looks like it's doing what you want it to do.
Cool. So now we can loop through kind of the second hash map or loop through the second string T. And
Okay.
this is kind of where probably the main functionality is going to be. Right? So if we loop through then T dot length. So then here, right, there's a couple cases, right? So if we look at the first case, right? So if map dot contains and we want, I think for clarity, I'm probably just going to use car. We'll do kind of, we'll refactor the top part later as well. So we'll do like car. Say like I'll just call it X for now equals dot car. So it'll kind of get us the car. And we can refactor the top part as well, just for cleanliness, right? So if it contains X, which is what we're looking for, right? Then you will.
Wait, go back a step. Can you explain what you're doing on 18 again?
Yeah, so on line 18, kind of looking at this portion up here, we use that car in a lot of places, right? So rather than have to continuously call s.carat or t.carat, I'm just going to store it.
Okay, so
Right,
as you're looping through T, you're storing what the
I'm
current.
storing what the current character
Okay.
is, right? So we'll kind of come back to what we do if it contains the key, because there's a lot of functionality there, right? But in the case, we know that in the case it does not contain the key, right? Then we know that that character was added, that it's
Okay.
like a different character, right? So we know we can return X, right? We know we can return that character, right? So now if we look at if it does contain the key, right, then we have to check what, like how much count of that character there is left, right?
Okay.
So we want to say essentially map, look at, we'll set it to an int, right? We'll call it map count, or probably car count, probably more accurate, car count. That'll equal map.get X, right? So it kind of gets the count for that character.
Okay.
So then we'll have an if statement. So if car count is less than 1, right? Then we know that like we don't have any more space. So this is an extra character that was added, right? So then we want to return X, right?
Okay.
In the case that that's not, if there is a count for it, then what we'll do is we'll just map dot replace X with map with our count -1. So kind of to walk through that again, right? We are essentially looping through T, right? Getting that character, checking if it's in the map, right? If it is in the map, then we check that there is a count for it, that like we still have availability to use that character, right? If there isn't, then we know that that's the character we're looking for, right? Because there's one extra of it, so we can return it. If it does have space, right, then we'll just decrement the count, right? And then in the case that it isn't in the key at all, right, then we know it's the character we're looking for, so we can just return that character, right, if that makes sense.
Yes.
So in this case, we should never be hitting this kind of case, right? So I think we can just remove this, right? Because I think it says that we're guaranteed, I figure, to always get a different character, right?
Yeah, look at the second constraint.
Yeah, I mean there.
No, not the example, the constraint.
Yeah. Okay, so
Yeah.
t dot length is always greater than s dot length, right? So a character is always getting added, right? So that makes sense, right? There is a quick kind of edge case that we can kind of solve. So if you look at example 2, right, there is the edge case in that s is empty, right?
Okay.
And thus t is the solution, right? So we could probably, before we kind of do all of this, right, if we have a quick if statement that just says if s dot length is equal to 0, right, then we can just return t, right, because we know it's the solution for a fact.
Right. And we can do this to improve efficiency.
just to improve efficiency. I mean, our solution should still work, so we can kind of comment this out, and we'll add it back later, right? Because technically, if we look at the second solution, right, we would just skip this for loop. The hash map would be empty, and then we would hit this else statement, right? Because it doesn't contain the key, right? But kind of a simple optimization.
Okay.
So this should run. So if we run incompatible types, string cannot be, oh, I guess I'll remove it. Or I can just do I'll remove this optimization. It sucks, but I'll adjust it. T.car at error cannot find symbol. Oh, okay. I misplaced that. Missing return statement. So we're missing a return statement. So kind of look at this, right? I mean, I figure there is some case in which neither of these get hit, possibly.
So look at what you're returning, and then how can you make that something generic that will return?
So right now I'm returning X, which is a car,
Mhm.
right? So I mean, like, I mean, should I be returning? Let's return just an empty car here, just to see like where we're hitting this, if that makes sense. So should I be returning like something empty? Empty character. So I figure I should possibly then in this case, what like, so I figure it's because it wants me to return it in some case that like this
Yes.
doesn't have length or this doesn't have length. I mean, it's not a possibility in the case of the problem, right? But I guess just to make it so that kind of Java isn't upset with me, right? You could do like some results, right, equals some we'll just set it to nothing for now. Or I think that'll probably error out. Set it to like A for now. Then we'll just return results, right? And we'll just set like set result equal to X. And then we can break, right? And we can do the same thing. Results equal to X. And then break, right? And that should hopefully work. The string cannot convert to a car. It's single quotes, David. There we go.
Nice, awesome. Why don't you try to submit it now?
Cool. Yeah, so it looks good.
Awesome. What would you say is the time and space complexity for this?
Yeah, so I mean, if we could put it up here. So the time complexity for this is just going to be O of n plus m, right? Where n is the length of S because we have to traverse it entirely. And then m is the length of t, where we might possibly have to traverse that entirely as well, if that makes sense.
Yes.
Yeah, and then kind of the space complexity for this is just going to be kind of O of n, where n is kind of the space of S, or the length of S, right? However many characters S has.
That was easy.
Awesome. Good job.